Bacterial diseases have been the bane of humanity's existence since the first civilizations. Perhaps the most memorable was the Black Death of the mid-1300s, which saw the death of 30 to 60% of the European population. Subsequently, a multitude of other common infectious bacterial diseases, such as pneumonia, tuberculosis, and cholera, caused millions more deaths, with only minimally effective treatments to slow their progression. During the course of World War I, bacterial diseases were so rampant and uncontrolled that they became one of the war's biggest killers. Countless soldiers were put out of action due to its disease, fearful not only of enemy bullets, but also the brutality of nature. World War I served as a wake-up call, not only for military strategists, but also for those in the medical field. After the First World War, the massive death toll from wound infections and contagious diseases motivated not only military advancements, but also groundbreaking medical achievements and discoveries.
At the forefront of this was penicillin, discovered by a Scottish physician and microbiologist named Alexander Fleming. His breakthrough came from an accidental discovery in September of 1928, when he returned to the lab from a vacation. Some spores had contaminated a test plate he forgot to put away, and he noticed a zone around the fungi where the bacteria did not grow. Theorizing that there might be some antibacterial effect, he isolated the mold, identified it as part of the Penicillium genus, and named it penicillin. He conclusively determined that penicillin had a powerful antibacterial effect, but it stayed as a mere laboratory curiosity for nearly 2 decades. Although interest in penicillin was insignificant for almost 2 decades, we now know that it had a massive impact on the treatment of bacterial infections, helped give the Allies a significant advantage during the events of World War II, and was a vital frontier that still is being explored by medical professionals to this day.
Penicillin emerged during the mid-1900s as the Second World War began to unfold. Its effectiveness was first displayed in March of 1942, when Ann Miller, hospitalized for a month due to streptococcal infection, and nearly on her deathbed, was given a shot of the drug. She made instant progress in her recovery overnight. Thanks to her doctors' and scientists' lobbying, the UK soon fully embraced the new wonder drug. However, they encountered difficulties in mass production. Most suitable factories in Britain were tied up producing war materials and other vital medical supplies for the war in Europe. Since funding was low and the British government did not have the resources to mass-produce penicillin, they went to their industrial ally, the US, to take over the effort. It was in Peoria, Illinois, where penicillin would start being mass-produced. A process known as deep tank fermentation was used to propagate penicillin in increasingly large containers until they were finally moved into giant fermenter tanks. As a result, they manufactured about 2.3 million doses of penicillin before the Normandy invasion, shifting the war's balance in their favor. Just one penicillin unit could stave off and treat bacterial infections for each wounded soldier, a new frontier in preventing diseases from killing off potentially recoverable casualties, and allowing the military force to stay strong and prevent unnecessary deaths. This was a critical advantage that the Allies held over the Axis and was one of the factors that shaped the outcome of World War II. Penicillin saved the lives of at least 100,000 Allied soldiers over the course of the war, and by the war's end, the United States had produced more than 6.8 trillion units of penicillin.
The effects of penicillin were not only incredibly valuable during the war, but also saved many in civilian life after as well. Penicillin's reputation received a massive boom in the Second World War, so the government began pushing for its widespread usage in the general population. Soon, penicillin was a common sight in every American pharmacy and was hailed as a miracle drug. Streptococcus pyogenes once resulted in 1/2 of all post-birth deaths and was also a leading cause of death in burn wounds. Staphylococcus aureus, another common bacteria, was fatal in approximately 80% of infected wounds. Countless other bacterial infections like pneumonia and cholera were also infamous killers. However, penicillin changed all this, effectively curing most of these once terminal diseases. For example, the introduction of penicillin in the military single-handedly reduced the death rates from pneumonia in soldiers from 18% to 1%. This allowed for rising life expectancy in the United States, and its influence would spread globally, especially in the increasingly international trade sector. The stunningly successful effects of penicillin in Europe, in particular, can be shown in Italy, when in 1947 the drug was first officially introduced to the country. The mortality rate for penicillin-sensitive causes of death more than halved in 1948, just 1 year later. Overall, penicillin significantly increased the quality of life for not only soldiers during World War II, but also civilians in the post-war era, creating widely available and convenient treatments that thoroughly destroyed any infectious bacteria. However, this wasn't always the case. Leading up to the 1930s, there were no effective antibiotics. Whenever someone caught a bacterial infection, they would either fight it off with no medical treatment or, in most cases, suffer life-threatening and often lethal complications.
The first antibiotic was created 10 years before penicillin was first used. Sulfa drugs, created in 1932 by German scientist Gerhard Domach, were the main antibiotic going into World War II. Sulfa drugs work by binding to and inhibiting an enzyme called dihydropteroate synthase, which is required for bacterial reproduction. Since sulfa drugs work by preventing bacterial reproduction, but not by actively killing bacteria, some bacteria would survive and reproduce, creating sulfa-resistant bacteria. As a result, effectiveness decreased over time as sulfa-resistant bacteria proliferated. Compared to sulfa drugs, penicillin has a more aggressive mechanism of action. The beta-lactam ring found in penicillin binds to proteins of the bacterial cell wall and disrupts its integrity, resulting in bacterial cell lysis and death. This bactericidal property of penicillin is why it was vastly more potent against many of the common, disease-causing bacteria in the mid-1900s, and why its usage skyrocketed to become the frontrunner in antibiotic therapy.
Penicillin, when you mix that with blood, kills all the microbes and leaves the blood cells intact. We're going to advance. There'll be new antibiotics found which will affect microbes that we can't kill now. Because we can't kill all the bacteria, the ordinary bacteria, and we can't kill any of the viruses.
Penicillin, despite its age, is still commonly used today. It has also led to the creation of more efficient versions, such as amoxicillin, that can target and kill a broader range of bacteria than previously imaginable. Currently, modern antibiotics, most originating from penicillin, can protect and effectively treat common bacterial infections. In addition, refined mass manufacturing processes have led to penicillin and its derivatives becoming easily accessible and relatively affordable, and have led to bacteria-related deaths significantly decreasing worldwide. Penicillin is one of the major keystone marks of medical evolution. Common antibiotics used for treating something as simple as a throat infection to life-threatening illnesses such as pneumonia have their earliest origins in penicillin and the scientific communities that expanded upon Fleming's discovery after World War II. In the words of Nobel Prize biochemist Gertrude B. Elion, quote, "I had fallen in love with a young man, and we were planning to get married, and then he died of subacute bacterial endocarditis. 2 years later, with the advent of penicillin, he would have been saved. It reinforced in my mind the importance of scientific discovery."
Throughout human history, many of our achievements have resulted in the death of millions. Guns, the atomic bomb, and chemical gas to name a few. Yet penicillin serves as an example that not all of our achievements have resulted in bloodshed. It has been one of the main reasons life expectancy has almost doubled in all countries, and is also a beacon of human ingenuity. Once a devastating microorganism with no viable solution, bacteria can now be treated with something as simple as a prescription from a local pharmacist. And it all came from never-ending innovation to change the status quo and a little bit of luck.